Welcome again. Thank you again for joining our allnex webinar. My name is Michaela Fusco. I am the Global Marketing Manager for Industrial Coating. And we're all very excited to be able to share with you today our latest developments on the Waterborne UV technology, and in particular on how we are expanding on our sustainable product offering, in particular for the industrial wood market. What we will see today, we had already the honor to present at the recent Wood Coatings Congress of last October in Amsterdam. And we wanted to make it available, that content, to all of you, our customers, both those who were not able to attend the event and those who wanted to have the opportunity to further deepen and discuss the topic with us. As you know, Waterborne UV is the fastest growing technology still in the wood coatings market. And this is thanks to the fact that it's combining the environmental and VOC benefits of water-based systems with the performance and the productivity advantages of UV. And allnex is strongly committed to its leadership and technology pioneer role for this technology. So today, I will now leave the stage to my colleagues, Michelle Tillmans, Associate Research Fellow, and Xavier Deruyttere, who is our Technical Service and New Business Development Manager in EMEA.
Thank you, Michaela. Thank you. It is indeed our real pleasure to introduce our most recent developments on water-based energy curable polyurethane dispersion that extend our sustainable product offering for wood applications. Like you probably know, our company allnex is present on the coating market with 4 main technologies that are the pillars of sustainable development. Our lecture today is focused on radiation curable products for use in industrial coatings and in particular for wood applications. allnex is committed to a greener and sustainable future. As you can see on the slide here, we are therefore focusing on 5 differentiated sustainability pillars. First, the use of safe materials, and more also the use of sustainable resources, the control of air emission, the benefits of circular economy, and the focus on energy efficiency. Most of radiation curable products fulfill several of these sustainability requirements, in particular for safe materials. For instance, many products are tin-free. For air emissions, considering products contain no added solvents, and also for energy efficiency, meaning the curing step is very favorable here, also considering the new trend for using low energy LED lamps. More than a decade ago, the radiation curable technology and the water-based technology could be merged together with the development of novel energy curable polyurethane dispersions that we often call UVPUDs. These products are really unique because they combine a certain number of features that bring substantial benefits over their parent technologies. You can see them all on the slide. First, they are stable colloidal dispersions and present very low viscosities, which make them suitable for spray application on wood. They do not use any reactive diluents anymore, and they have a low film formation temperature. But they can indeed become very hard due to radiation curing, which is bringing mechanical and chemical resistance to the coating due to the dense cross-linking network that is created. They can be dried and cured with low energy, which is certainly contributing to their excellent productivity. Third, they are also polyurethanes. With a good control of molecular weight, it is possible to tailor the right polymer flexibility and achieve a very large gloss range, targeting medium to low gloss, but also high gloss surfaces with mirror effect. Due to their polymeric nature, the coatings can also be tack-free before cure. And finally, fourth, they are also functionalized polymers that present excellent colloidal stability without the use of any emulsifiers. Their functionality usually stands for good adhesion on wood, but also eventually on plastics, while they can be used for 1K or 2K dual cure if required by the application. Due to their amphiphilic nature, they can be made resoluble in water before cure. It is possible to integrate these features in a straightforward sustainability model inspired by life cycle analysis. The model does have three distinctive axes, like visible on the slide here. For the composition, product can be made from safe or renewable raw materials and typically have a low volatile organic content, like already discussed. In a second perspective, we need to consider the performance in use. The products have a low film formation temperature, and therefore they do not need the use of extra co-solvents, which are often referred as coalescing agents, in order to make a good film. It is reducing dramatically the volatile organic content of the formulation. Also, the product can be resoluble in water before cure, meaning that the dried coating can be easily cleaned without the use of solvents. The trend for high solid contents minimizes also the drying energy, and the use of highly reactive products and formulation allow the use of low energy cure, for instance using LED lamps. The third and last dimension is lifetime and disposal. Most products offer high durability, or even weatherability in the case of outdoor exposure. And an increasing attention is also provided to the recyclable character of the raw materials and the final products, as well as their biodegradability. That brings us to the front end of innovation.
Indeed, and all this leads to an interesting portfolio of products for different applications. So I'm looking to the middle of the slide. Different application, different cycles, different coats, primers, top coats, but also self-sealing systems. Also different levels of performance. Can be high performance, but can also be value and use, like we say, fit for use, meaning that products do the job without over-engineering. Can also be clear applications, white, colored. We know that for colored systems you need a much higher hardness. Can be indoor as well as outdoor. Most of the products will be oriented to industrial applications, but we also have some specific developments and products for what we call field applied applications. And then last but not least, gloss is very important. So we have specific developments and products for high gloss applications as well as for matte.
Okay, and 4 new products were recently developed for these wood applications. When you look at the slide, you can see that they are each characterized by an innovative step, which is always linked to the particle. Its morphology, its stabilization, its functionalization, or its composition. We are entering here in a fascinating world, the world of nanoscale particles. When you imagine monomodal particle dispersion at 40% solid content, which is often the case, you have to realize that the distance between the particles is only about 20% of their diameter. Yes, they are really so close to each other, and at the same time, they are stable, even in more extreme condition of storage. It's indeed very, very surprising. And did you know that 1 gram of particles having all a diameter of 100 nanometer, which is a standard for these kind of products, Well, this 1 gram will develop a surface of about 100 square meters. The nanoworld is really full of surprises. So let's go immediately to our new products now. First, we are going to look at the particle morphology, introducing swollen polyurethanes. Products with hard-coat properties after cure were developed as small molecules with a very high acrylate functional density, and since they were viscous liquids, they found their existence in water as an emulsion. That is the situation that you see on the left of the slide here. These products can have a very high solid content, up to 65%, associated to a big droplet size, up to 1 micron. But we were able to develop recently a new dispersion, keeping the same features. The product is made from highly functional acrylate polyurethane particles, having thus a higher molecular weight, as you can see on the slide, but that could be swollen by the compounds of the previous emulsion. And that is the situation that you see on the right side of the slide. The particles can thus be seen as a kind of reservoir for highly functional molecules, but the new products keep all the attributes of a polymer dispersion in water. So, how does the product look like?
Well, when we first look to the wet dispersion properties on the left, we see that UCECOAT 7230 has a high solid content of 45%. High because the standard in Waterborne UV is 35 to 40% in solids. The pH is above 7, which is also standard, of course. The MFT, so the minimum film formation temperature, is below 5, which is very low, which is important as it does not require addition of co-solvents, so no extra impact on VOC. And UCECOAT 7230 is also tin-free, like all our new developments already since a couple of years. Now, coming on the coating properties on the right side, all the value of UCECOAT 7230 is related to its extremely high concentration of acrylate functions. So, and making this resin very effective as a modifier resin for improving hardness, scratch resistance, and stain resistance. So, it's a bit similar to 100% UV formulation, where, for instance, a 6-functional urethane acrylate is commonly used to improve the final properties. Here, in Waterborne UV, we recommend UCECOAT 7230 as a performance booster in the same way. On the next slide, we have an example, and it's a very extreme example, since here we blended UCECOAT 7230 with Residrol 6191, conventional alkyd emulsion that does not contain any reactive acrylate functions on itself. So all the UV cross-linking is coming from the 7230. And it's an interesting example since it also shows a way to introduce renewable content in waterborne UV dispersions. So in this case, here it's a 60-40 blend. We obtain a renewable content of nearly 20%. And on the left, you see the profiles. The yellow spots on the graph indicate which properties remain unaffected by the blending. You'd see the stability, the aspect, the gloss, the chemical resistance. And of course, okay, there is also some impact on hardness and stain resistance. But this is very decent considering that we blend here with 40% of an alkyd emulsion. So all this would not be possible thanks to the extreme high double bond concentration of the 7230.
And now we are going to look at the particle stabilization this time, introducing nonionic polyurethanes. The stability of polymer dispersion is usually obtained from the electrostatic repulsion between negatively charged particles. Look at the picture on the upper right of the slide here, and consider we developed a proprietary technology where it was possible to introduce in the polyurethane polymer a diol bearing a long polyethylene oxide chain. This is standing for effective non-ionic stabilization due this time to the steric repulsive interactions between the particles. The products made with this approach have a bundle of interesting properties like can be seen in the next slide. So, Xavier, can you give us some perspectives on that?
Sure. On the wet properties first, there are two special characteristics to mention. First, it's a label-free dispersion. And second, and this can be associated to the non-ionic stabilization as explained by Michel, the resin shows a very good pH stability during aging. And therefore we expect for the UCECOAT 7738 a lot of robustness and stability into the formulation. So cured films with UCECOAT 7738 develop a good hardness, making this resin suitable for both clear and pigmented coatings. Especially in white pigmented applications, we also observed a very nice high gloss with mirror effect. And this is remarkable for this resin because UCECOAT 7738 is a tag-free resin, so physically drying. And physically drying resins, we know of that it's much more difficult to obtain this mirror effect with them. But of course, it's a big advantage to be physically drying because it means less dust take-up, so less risk for defects in your high gloss coating. On the next slide, we see an overview of the performance profile of the UCECOAT 7738. The profile of the 7738 is here compared with the profile of the 7788, our label-free dispersion that we discussed already a bit earlier. The profiles are quite different. UCECOAT 7788 is a fit-for-use resin, more suitable for clear coatings, and UCECOAT 7738 is clearly more performant, enabling good performance in white pigmented applications. An interesting note is also that both dispersions can be blended in high gloss applications. We got quite good interesting results with an 80-20 blend. So 80 for 7738, 20 for 7788.
Okay, and now we are going to look at the particle composition and introduce functional polyurethanes. And please have a look at the left of the slide. In fact, yellowing on cure, is it with UV light or electron beam, may occur during product application and typically disappears after a few hours. It can, however, cause some difficulties for online color matching in specific industrial lines. Root causes are not well identified, but the phenomenon is clearly differentiated from long-term yellowing associated to polymer degradation during the weathering. allnex developed a proprietary polymer modification for the reduction of photoyellowing and consisting of the reaction of aliphatic isocyanates on the polyurethane backbone with aliphatic carboxylic hydrazides. The specific structure that you obtain, and that you can see here below on the right side of the slide, is thus obtained, and although the mechanism is not very well understood, it is anticipated that the reduction of the yellowing is coming from some metal complexation or oxidoreduction that is involved with this specific kind of structure. Now we'll see what it brings in practical terms.
Well, in practice, we confirmed the lower yellowing upon cure of the 7510. It can be a real advantageous in those applications and in those productions where the color matching is done immediately. But in general, we can position this 7510 also as a fit for use resin, similar to the 7788, but with a higher hardness. And we see more of that on the next slide. So there you see the two profiles. The 7788 we know very well. It's a standard in our range. It's more flexible. It's tough. While the 7510 is clearly more hard and has these aspects of less yellowing upon cure.
Okay, and finally we are going to speak about particle composition again, but introducing modified polyurethanes. Like you can see in the slide here, the synthesis process of UVPUD implies the reaction of different constituents in the presence of polymerization aids like catalysts or radical inhibitors. And a typical polyurethane structure is essentially composed from, on one side, the polyisocyanates, on the other side, the mandatory acrylated polyols, but also typically some long-chain polyols and other functional polyols, typically the dimethylpropionic acid, which is providing, after its neutralization, the anionic functionality required to provide a stable polyurethane dispersion in water. We developed here a proprietary composition that merges the long-chain polyol with the functional diol, bringing thus a functional long-chain diol instead. So let's look now what it brings in terms of product benefits.
The number one benefit is related to cost effectiveness. The number two benefit is that this binder is highly compatible with a lot of dispersions, waterborne UV or conventional. This offers a lot of possibilities to formulate and balance cost performance. And the number three benefit is that UCECOAT 2501 is a binder with very good adhesion properties. So for this reason, our first recommendation is to evaluate the UCECOAT 2501 for primer applications, alone or in combination with other dispersions. For top coat applications, on the next slide, UCECOAT 2501 can be a good blending partner, especially in combination with hard and reactive dispersions, in order to balance the reactivity of the systems. For instance, to fine-tune the drying or to improve adhesion properties. So on the graph, we see three profiles, UCECOAT 2501 as such, and then two blends of UCECOAT 2501, first with UCECOAT 7655, and then with UCECOAT 7734. So UCECOAT 7655 and UCECOAT 7734 are two standards in our range, two hard and reactive UVPUDs designed for pigmented applications. And it's interesting here to note that and to see that UCECOAT 2501 has a clear impact on the reactivity in formulation with these binders, hence also will improve the water release and the adhesion properties, but without significant impact on the coffee resistance and the chemical resistance.
Okay, it is now time to come to some conclusions of this presentation. I hope that we could convince you that allnex is offering a comprehensive range of waterborne products for food application and covering large market needs. We showed also that we did extend our product offering with 4 new products in our portfolio, supported by clear innovation and technological differentiation. And finally, we highlighted the strong sustainable position of the technology and the wish of our company to be a driver for green and environmental friendly coatings.
Thank you, Michel. Thank you, Xavier. So we have come at the end, indeed, of the presentation. We have time now to take your questions. As Laura said in the message that was shared with you in the beginning, you can use the chat box to enter your questions. So I'll make sure to read them and ask them to Michel and Xavier. And in the meanwhile, I see there is one question. I think this is, I'll start with Xavier. So Denny is asking, can we blend the UCECOAT 2501 with the UCECOAT 7230 to boost its performance?
Sure. This is in fact a very good idea because here the 7230 alone is so hard, and with the UCECOAT 2501 you can bring in flexibility and improve the adhesion of the combination. So I think it's really an interesting match. Also, the 2501 will improve the cost-performance balance.
Okay, thanks, Xavier. While I see maybe more questions are coming, I will start. Maybe I have a question, Michel. I mean, as you have given us this great picture of actually the vision in terms of innovation for water-based UV. I'd like you to share, I mean, when you look into the next 5 years, what do you believe will really be the key drivers for innovation in the wood coatings market?
Okay, very interesting question. In fact, I think that the aspect of the product processability, closing also the gap between solvent-based and water-based products, is something that will have a growing consideration. And I'm thinking in particular to the drying efficiency. Also the possibility to go to higher solid content, the possibility also, like we are starting now to have low energy curing, that all these things will need to be considered. On the other side, I think that, like we showed, the aspect of increasing the renewable character of these products will really be growing in the future, and we will see products appearing with really more bio-based content in it, while keeping in fact the very good performance of the product of this generation. And also at the same time, of course, we will still continue to look at the use of safe materials and lowering the exposure to substances of concern. And I would say that, in my opinion at least, we should see also in the future some more smart products for smart coatings, where in fact the high performance is combined with another feature that needs to be defined by the market and the customer needs.
Okay, thanks, Michel. I see in the meanwhile that there is a question from Roger about the DSL registration of the ratings for Canada. So I cannot answer one by one. I saw that the UCECOAT 7230 is and the UCECOAT 7510 is, but I'll make sure I get a confirmation to you by email today. And waiting if there are more questions. There's also one questions I wanted to ask Xavier. I mean, we have looked at quite a wide, offer in terms of new grades. Of course, I mean, based on your understanding and knowledge of the potential of each of those, where do you think that these grades are really bringing most value to the applicators and users of the coatings?
Okay. So for UCECOAT, let's start with UCECOAT 7230. I think this is definitely a very interesting one for the furniture foils, because its high hardness it will bring value there, especially in the thinner layers that are applied on these furniture foils. For UCECOAT 7738, I would first think of the high gloss applications, especially the combination of high gloss mirror with its physically drying properties will bring their value in terms of robustness and ease of use. And then for the 7510, I see it as a harder complement to the UCECOAT 7788. Also, and this could be an advantage in for some applications, we found that UCECOAT 7510 is easier to mat. So this could be another value. And then for the UCECOAT 2501, there I see the lower reactivity of this dispersion as an advantage to balance the hardness with adhesion and drying properties.
Thanks. And we have focused a lot, of course, today on our latest innovation for interior applications in wood. But what about the future of the water-based UV technology for exterior applications?
Well, at least based on all the demands we get for waterborne UV for outdoor, we expect a nice future here, a lot of growth. I'd like to mention that our star product for outdoor is UCECOAT 7689. Which is quite different from all the dispersions we discussed today, because it's based on a different chemistry. It has a polycarbonate backbone. It's also the most flexible UVPUD in our range. And also for this reason, we know and we see that also the 7689 can be used for interior applications to flexibilize the dispersions and the formulations.
Thanks. And I think that also Danny was asking about which one of our UCECOAT grades will perform best in exterior applications, which I think, Xavier, you just answered in it. That's UCECOAT 7689. Yeah. And yes, we do have data on exposure that we can share. So Danny, we will share with you after this session. I hope you have enjoyed the session. In case you still have questions, please don't hesitate to contact us, either through the sales, the account manager that you are in contact with, or to our general email address that is on this slide. And we're very happy to continue this discussion. Thank you again for joining, both from Europe and from the US and Canada today. And I see, though, there's maybe another question coming, so I'll take an extra minute. Okay, that's a thank you. Thank you very much.
Thank you.
It's been a pleasure. And again, please don't hesitate to contact us for any more questions on this or any other topic. Thank you. And
have a nice
day.
Yeah, bye-bye.
Goodbye.